Alright, we are taping, and we're going to do this on a very small screen here in the great hopes that we'll be able to do something else with some of the other things. This is the end game, if you would, for all of those who don't necessarily want to grab up how to add vectors, but you still need to do that. And here's what we have. We have layers set that are standard, somewhat, front-end loaded. And we'll see whether that actually gets me out of the layer stuff. It's going to be a pain in the butt to close. Alright, we got layers. We've got things on things like geometry spine. We have all of our forces beginning at the right spot on the structure. Each of them are on a layer that makes sense, right? And I want to point out that they're all on the force applied, and each of them have a different line type assigned to them. That's for management. So 10 force, 11 force, 12 force, 13 force, so you could go with 14 force. I will quickly show you how one could go about for the mimicking, if you would, the distributed load, and that would be to do something like force applied, take a line from maybe the end point here, take it down at a distance of at 1 angle 270. I do that because my ortho does not work. And then do a minus array. I select my objects here, rectangular, number of rows 1, number of columns 20, and distance between 1. And I'm going to go ahead and leave that one in and then just go ahead and change this one here to the 14 force. You can see how much data you can pull. Now, of course, that wouldn't work on the things going up the page, but we're going to go with a line force and make that 15 force. I would generally not recommend you take it to that level. That's what mathematics is for, but you've basically got here now a distributed load of every a pound per foot for every foot. You've got all these things. They are all on the right layers, and your 0 point is known. You've got the reactions in the correct layers, and you've got names assigned to them. You can now go about using data extraction, and there's how you do it. Data extraction. I'll take it all the way through. You generally are going to use an existing one, but we're going to create a new one. We're going to save it out someplace where we know it goes. I'm going to go for, I'll just put it now, right now, in AO Spring, and I'll go ahead and add a new place and call it data extractions. Let me give it a name, moment calcs. This is going to be all about internal forces. Save it here. I'm going to select objects from the current drawing. Sometimes you'll grab a whole lot more. I'm going to grab all of my forces, including my reactions. You might want to pull the structure into another place, but you're going to grab all your forces there. You go to next. You go to next, and this, you tell it you only want some things, and the things you only want are the delta x, y, and z, the start x, y, and z, and in fact then the line type, which is going to be the thing that kind of differentiates. You can do this any way you want, but this is a pretty darn efficient way to go ahead and send this out to a CSV file. So each of these things are all important, but you can calc them. You want the line type. You don't need the line type scale. You don't need any of this. All you need then is the point of application, which is the start x, y, and z. And you have to remember that these come in an odd order. You grab all that, you hit next. You generally don't need to show the row count or the name column, right? And if you think about here, the line type is by layer on everything I grab. So I must not have grabbed everything that's correct. So the line type, we want to go back. Those by layers are going to be all the ones that were along the bottom here. So I'm going to hit cancel here and go back. Or I'll just go through this, remembering one thing I missed was all those single forces, and those by layers are going to be the line type. Those are all the individual forces going along the bottom. You notice here all those -1s are all going to be by layer. Everything else has got a force applied to it, so I'll continue through. Hit next here. You need to output the data to a CSV file. It may seem odd, but that's what it needs to be, at least from my general remembrance or understanding. Remember, I'm here. Within that, I don't want to be there. I have to know where I'm putting my stuff. I was putting it in Spring there, and I was put it in data extractions. I'm going to give that a temp name for me, but you need to put it as a CSV file. You'll see why in a second. You hit save, next, finish. It stuck all the data out. That is going to give you this ability then, as I explained before. I'm going to go right now and go into Programs, Windows, Office, Excel, and I'm going to show you how you then go about bringing that in. Though in the end you would want to do some linking, so all you do now is File. You go to Data. You're going to get external data from Text. Go out to where you know it is, which was out here on the Fall 2010, Spring 2010 data extractions. It is a CSV file. You hit Import. You generally don't need the first row. You remember that it comes in by delta x, the force first, and then the radial vector. It is comma delimited. You hit Finish, hit OK, and there you have it. There is your, if you remember it, these are all your forces. The bilayers, of course, were the ones that were the distributed load, and I grabbed up one extra thing here, and I don't know what that is. So really you only need to grab in these delta x, y, and z, the line type, and then the start x, y, and z. And from that you can end up sorting and doing all your calculations by using if statements to discount anything that is not part of what's in front of you when you do the section, if you would. Okay, I'm just going to print and post that out. That's how you go about doing it. And then you start processing that. That's a rich bit of data that can really help to do lots of things, but in the end it can't necessarily add vectors. You're going to need to do that.